Well, the question is prove that sin sine of 2x into cot of x plus 3 tan of x is equal to 4 minus 2 cos 2x cos 2x. So you are supposed to prove that sine of 2x into cot x plus 3 tan x is equal to 4 minus cos 2x. So first, what we'll remember is a few identities. I've already seen this. So I want to say that sine of 2x should be given by 2 sine x cos x, like that, 2 sine x cos x. Then tan of x is equal to sin of x over cos of x. That's an identity again. Then cos 2x, cos of 2x is equal to 2 cos squared x minus 1. What is left? Then we have cot of x is equals to 1 over tan x. So using these identities, we'll be able to show that this is this. So we start by where there is this, we write this. So I have 2 sine x cos x into 1 over tan x plus 3 tan x plus 3 tan x. So we start with this side to see if it ends here. Then we shall have shown as required. So in this case, what we have, but we also know that tan x is sin x over cos x. So if I'm having 1 over tan x, it means this I can write as 2 sine x cos x in bracket. If this is sine x over cos x, so it is cos x over sine x, cos x over sine x, the reciprocal of tan, plus 3 into sine x over cos x, like that. Then the second thing that I want to do is to divide each term. So I already have 2 sine that, then that is this, and that. So the next step, having put it in that form, 2 sine x into that, I can open the bracket. I can open the bracket and first let's see what we have here before I open the bracket. Let us see. Let's put this under 1 LCM. So here I have sin x cos x. This comes here, leaving me with cos squared x. This comes here, this divides this times, so plus 3 sine cubed x over this. So the whole of that, we have 2 sin x cos x. So this is this. That is that. But what is so straight away we should see that this divides this. And now we have 2 into cos squared x plus 3 into sin cubed x, like that. But cos squared x is equal to cos squared x. I can make this the subject. If I make this the subject, then I should be able to know what cos squared x is. So let me do that this end. So I know that cos 2x is equals to 2 cos squared x minus 1. That implies that 2 cos squared x is equals to 1 plus cos 2x. So cos squared x is equals to 1 plus cos 2x over 2. So where there is this, I will now write that. So I will say if I open the bracket, this will be 2 cos squared x plus 6 sin cubed x plus 6 sin cubed x. But now I want to rewrite this in this form. So it will be 2 into 1 plus cos of 2x over 2 plus 6 sin cubed x. This will cancel this. This will cancel this, and so I end up with 1 plus cos 2x plus 6 sin cubed plus 6 sin cubed x plus 6 sin cubed x. So it is 1 plus cos x plus 6 sin cubed x. So what do we have? Here, sin x cos x, this comes, it's cos squared plus 3. This comes here, sin x, so this is sin squared, not cubed. Sin squared. This is not cubed, it is sin squared. Sin squared. Sin squared, sin squared, sin squared, sin squared, sin squared. It is sin squared. This is sin squared x, sin squared x. So I can write sin squared. I can write sin squared. I can write sin squared as, so I say here that 1 plus cos 2x plus 6 into, this is sin squared x. I want to rewrite it by remembering that sin squared x plus cos squared x is equal to 1. That would then imply that sin squared x is 1 minus cos squared x. 1 minus cos squared x is 1 minus cos squared x, 1 minus cos squared x. One minus cos squared x. So we'll okay, just a moment. Well, we see that if we are up to here, then we need to remember the identity. We remember the identity that cos 2x is also equal to 1 minus 2 sine squared x. Yes. And so if that's the case, and we would want to rewrite this particular part in that form, then we'll make this the subject. So that's like saying that minus 2 sine squared x is equal to cos 2x minus 1. Dividing each term by 2, of course, we get sine squared of x is equal to 1 minus cos 2x over 2. So that's sine squared of x. So bringing it here means I'll be having in effect 1 plus cos 2x plus 6 into this. 6 into this. In other words, if I was to say 6 that, then it would be 6 like that. That's 3. Savia into 3. Okay, plus 3 into 1 minus cos of 2x. This is 1 plus cos 2x plus 3 minus 3 cos 2x. Collecting like terms, this plus this gives me 4. Cos 2x minus 3 cos 2x becomes minus 2 cos 2x minus 2 cos 2x. And that's our answer. So that's the answer to part A. Let's look at part B. Part B requires us to get exact value of cot, this part C, exact value of cot 1 over 12 pi plus 3 tan 1 over 12 pi. So we need to get the exact value of that. Now, for us to get the exact value of this, we realize that sin of 2x into cot x plus 3 tan x, we simplified to be this. And this is what we have. We have shown that this is this. But realize that now we just want for the inner, because it just cot x plus 3 tan x. So we have not included the other sine 2x. So it means that for us to work out part C, it will be 4 minus 2 cos 2x divided by sine 2x. Divided by sine 2x. And then we see that x is 1 over 12 pi. So let's substitute 1 over 12 pi into all that. If you substitute that, that will be, if you substitute it here, it will be 2 of this, which is 1 over 6 pi, cos of 1 over 6 pi, that is 4 minus 2 of cos of 1 over 6 pi, divided by sin of 1 over 6 pi. Now, if you check that using your calculator, you should find an answer which is 8 minus 2 root 3. 2 root 3. That becomes the exact value of part. It's part B, not C. The exact value of part B. It's not part C, of part B. So now we have part A and B. Let's see how part C looks like.